Okay, here's video 1 of my 3 video finished to the end. Now we're just going to talk about how exercise affects all these hormones, which is really what this has been leading up to since this class is about exercise. Really all we care about is exercise. So how exercise affects growth hormone, epinephrine, norepinephrine, glucagon, blah blah blah, all these things. Really briefly talk about aldosterone. Not really. Okay, so first off, we'll talk about growth hormone. Growth hormone we know causes growth in the body. Very simple. The hormone says what it does. Causes growth by increasing metabolism, causing your bones to be stronger, increasing building tissue, promoting hypertrophy, which is the strength of the muscles. So really it increases metabolism. This rises with exercise. So with exercise, it has been shown that this increases with exercise. And for the regulation of growth hormone, about when it's like released mostly, and there'll probably be a quick question on it. Let me just quickly about when it's released. It fluctuates with time. It bursts a lot. So you have like fluctuations, like little spigots of growth hormone. Now, for when it seems to be risen the most, it will be risen mostly when you're at night. Yeah, it has a diurnal impulse, so really that means like it's released mostly at night, growth hormone. So that finishes growth hormone. That's really all that we care about growth hormone. It's responds to exercise. It increases exponentially, well, not exponentially, but it increases proportionally with exercise. So that's growth hormone. And then the catecholamines, which are epinephrine and norepinephrine. We'll talk about epinephrine because this is really what we care about. Norepinephrine isn't really a hormone. Now remember that when we're exercising, we release norepinephrine first and then release mostly epinephrine. So we mainly release epinephrine with exercise. Epinephrine is the main dude released with exercise, but he's not released until like 75% of your max heart rate. But you release mostly epinephrine with exercise. Epinephrine's adrenaline, blah blah blah. We know what adrenaline does. Increases your heart rate, increases your blood pressure, increases the rate of glycogenolysis, so you break down glycogen, so you get more glucose. And also increases the rate you burn fat, which is why high-intensity interval training is good. That's what epinephrine does. Okay, now for cortisol with exercise. Remember, it's a stress hormone, so you release it when your body is stressed. When does your body get stressed? Well, it gets stressed when you're stressed because you're studying for this test. So you're probably releasing a lot of cortisol. But you also release it, now remember, this is released from the adrenal medulla. Just going over that again. Do not miss this. Now, you release cortisol from the adrenal cortex. Not what was I going to say. Okay, now, cortisol is a stress hormone. Now, stress hormone can be from resistance exercise or it can be from aerobic exercise. But you release it in order to get energy when you're stressed. So you release it when you're stressed. It increases glyconeogenesis, fat metabolism. You want to increase the amount of energy. So you can burn more proteins, blah, blah, blah. Glucagon, we already went over. You don't really release it when you're exercising. So that's really how exercise affects all these things. Now we'll finish the rest of this video with fluid regulation, since that's pretty much a really long question. Fluid regulation, you regulate the fluid in your body. Don't like the way I wrote that. We have one called ADH, Antidiuretic Hormone. Now, your body releases this when your blood volume is low. If your blood volume is low, that means, let's write that. Low blood volume. If your blood volume really is the same thing as blood pressure. If your blood volume is low, your blood pressure is probably low. So if your blood volume is low because you're dehydrated, hydration actually affects blood pressure because blood is water. So you drink water, you raise your blood pressure. Now, if your blood volume is low, your body has to absorb more water from your kidneys because it wants to raise its blood sugar, blood pressure, same blood sugar. So your body recognizes and you release ADH. I don't know if you have to know where it's from, but it's released from the posterior pituitary. So your body releases ADH. ADH goes to the kidneys. So it goes all the way down to the kidneys, acts on a part of the kidneys because kidneys will pee out water. Urine is water, hopefully everyone knows that. So it acts on a part of the kidneys called the collecting ducts, and you reabsorb water. So all the water that you would have peed out, I mean you still pee obviously, all the water you would peed out gets reabsorbed into the blood, so you increase your blood sugar. Your blood volume. So you increase your blood volume. So you reabsorb water. Now, if you reabsorb water, you're not going to have a lot of water in your urine. Your urine now will mostly be solutes, such as not really glucose. You're not really peeing out glucose, but it'll mostly be sugar. It has the same thing as glucose. It'll mostly be, I can't really think, potassium, sodium. That's a good one. Calcium. It will be things that make your urine concentrated. Can't speak right now. But your urine will be darker because you're absorbing more water. So when your urine's dark, I wouldn't say that but if your urine's dark, you're absorbing a lot of water from ADH because of that. So you're reabsorbing water. So ADH will cause your urine to be dark. If your urine is clear, that means you're peeing out a lot of water. You must not use a lot of ADH because you're peeing out the water. You didn't absorb it. So that's ADH. Now the next one is aldosterone. Aldosterone is the more important hormone because ADH really regulates your blood sugar, your blood volume on an acute level, like right away, like if you need it. Now, fun fact is when you're actually alcohol inhibits ADH, which is why you pee a lot when you're drinking alcohol. But also, okay, so now we'll talk about aldosterone. Aldosterone is released from the adrenal cortex, just like cortisol, but aldosterone is in response to low sodium, not technically low water, but low sodium. So also low blood volume. So it kind of is response to low blood pressure or low blood volume, whatever you want to call it, but it's mostly because of low sodium. Aldosterone mainly increases the absorption of sodium, but water follows sodium, so if you increase sodium absorption, you must increase water absorption. Now, aldosterone kind of has few more steps you have to know. Now, we'll talk about them. So first, what happens when your blood sugar is low? What's going to happen is your kidneys, it starts with your kidneys. So your kidneys release something called renin. So your kidneys actually release a hormone. Renin then goes up to your lungs, goes all the way to your lungs, and activates an inactive hormone called angiotensinogen to angiotensin 1. Angiotensin 1 then gets cleaved to angiotensin 2. So it gets cleaved in the lungs. Angiotensin 2 then goes to the adrenal cortex and releases aldosterone. So it's a little pathway. I'll memorize it. Blood sugars, not your blood sugar. Why do I keep saying that? You have low sodium in your blood or your blood volume's low. So the scene is your kidneys to release renin. Renin then goes to your lungs, very important to know, and releases angiotensin 1. Angiotensin 1 then gets cleaved to angiotensin 2. Angiotensin 2 then goes to the adrenal cortex and releases aldosterone. Now, it's very important. The thing that cleaves angiotensin 1 to angiotensin 2 is called ACE, angiotensin converting enzyme. This is what ACE inhibitors do. ACE inhibitors kill this guy, stop him. If you stop this guy, you can't form angiotensin 2. If you can't form angiotensin 2, you can't form aldosterone. Thus, you can't increase your blood pressure. So that's why ACE inhibitors are blood pressure medications. So you do all this stuff. Aldosterone then also goes to your kidneys. Instead of increasing the absorption of water, it increases the absorption of sodium. Water follows sodium, so by osmosis, and thus you increase your blood volume. And then you also get into more detail about osmolarity, all that good stuff. I wouldn't worry about that, but aldosterone increases your blood sugar, your blood sodium level by doing that. As you can see, I have a lot of espresso. The only thing that's keeping me up making 20 videos after a 70-hour work week. But anyways, you do all this stuff and you get aldosterone. Aldosterone is very, 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 very important because the other hormones aren't life or death, but aldosterone is life and death because it controls your sodium and your blood pressure. So that's pretty damn important. So this is pretty important. Okay, so this is the first video of my 3 summary to whatever. Yeah. So we'll see how well this does because I have like 10 questions left. Nope, that's not the start button.